Now we are live.
Shall we wait for another 2 minutes? We'll wait for another 2 minutes before we start. Good morning, everyone. Mr. Alok, can I please share my screen? Thank you.
Timmy, can you move closer to the mic, please?
Okay.
And can you please come in front of the camera or move the camera? We cannot see you.
Just a moment. Okay. Can you hear me now?
Yes.
Good morning, everyone. Thank you for joining. So, this build-a-thon on AI/ML driven low latency closed loop control is essentially the very first phase of this AI/ML challenge. The mentors associated with it would be giving overview of all the activities which are part of this 4-month-long build-a-thon. To begin with, this is the flyer which we all have already seen. Registration link for the build-a-thon is given here, as you can see. The registrations would be closing on the 12th of August. So beginning with an overview of this challenge, this is essentially to provide a platform for students and professionals to participate in the global pre-standards activity and the Build-a-thon challenge that is related to AI/ML in 5G networks. As I told, it is a 4-month-long activity which would be carried out in phases. The major objective of this activity is contribution towards standards, which would be including writing technical reports, publications, etc. The teams that are registered will be getting continuous support from the mentors from IIT Delhi. At the end of August, we are planning to have another face-to-face workshop at IIT Delhi, where we'll have India and EU experts on board. The winning team will be getting a free study visit to EU. As I told you, the registration link is currently available. It is available in the chat box as well as in the flyer, and the registration closes from the 12th of August. This is the agenda for our webinar today, beginning with an introduction to the activity by Professor Brejesh Lall, Professor, Department of Electrical Engineering, IIT Delhi. We'll have a detailed background of this activity, both at India and global level, by Mr. Vishnu. He's from ITU. Then the application areas, problem statements, and its details would be all covered by Dr. Arzad Alam Kherani, Associate Professor, IIT Bhilai, and Muneeb, who is a PhD research scholar from IIT Delhi. All the participants, if they have any questions or any doubts, they can discuss the same with the mentors following this discussion. So introducing to the activity and the role of IIT Delhi, we have the first speaker, Professor Brejesh Lall. Professor Brejesh Lall completed his PhD in 1999 from IIT Delhi in the area of multi-rate signal processing. He has been a faculty member at IITD since 2005 in the electrical engineering department and has contributed to research and teaching in general area of signal processing. He has earlier also served as the head of Bharati School of Telecom Technology and Management at IIT Delhi, and he is the coordinator of two centers of excellence, Airtel IIT Delhi Center of Excellence and Ericsson IITD Center of Excellence. He is also in charge of an IoT laboratory that is set up in collaboration with Samsung. He has mentored 5 startups in the area of virtualization, geofencing, UAV-based solutions, and recommendation and data mining. He actively participates in building and deploying technology. He also has served as an expert in numerous government and private agencies in aspects related to signal processing. I now request Professor Brejesh Lall to kindly give us an overview of this activity.
Morning, everyone. Welcome to this Build-a-thon. Before we get into the details, which of course Arzad and Muneeb will be looking at, and getting an idea of how and why such Build-a-thons are organized by Vishnu ji, who is in our midst, I will give you an overall perspective of this particular activity, a bit about IIT Delhi and the kind of work that's happening here. So, bring up the haptics slide, please. So there's one slide that so this is of course a brochure that all of you should have already got. This is what you should use for any details that you need. The contact details of people you can you can write to or get in touch with in case you have questions are also available here. Timelines and other details will be shared with you today. So can we move to the haptics slide, please? Yeah. So right. So there are 3 things primarily that I will try to touch upon in the next 10 odd minutes. The first is the genesis. So this activity is a result of two ongoing efforts in the group here at IIT Delhi with IIT Bhilai as a very close partner in the collaboration. So one work is building the indigenous test bed, an activity that started about 4 years ago and was culminated a few months ago. So that has resulted in multiple test beds coming up all over the country in various academic institutes. So we have one here at IIT Delhi as well. But the part of the test bed which is of particular interest to us is the one that handles MEC related activities. So we were in some sense, along with IIT Bhilai, the lead group in the MEC related activities, and which has resulted in us having a reasonably stable and capable specifications compliant MEC setup here at IIT Delhi. So this is one aspect that has led to this Build-a-thon happening. The other aspect is the interest in newer modalities such as haptics and newer tools such as AI/ML. So the group also strongly believes in AI/ML becoming the tool of choice in the applications in times to come. And haptics, tactile internet is something that you all must have heard a lot about. Is something that is touted as the next version or generation of internet as it evolves. So what tactile internet involves is extreme low latency and extremely high availability and accuracy. Now these were concerns that kept on becoming more and more important as you move from speech to video, But now once you move to haptics, latency becomes an even bigger challenge. Availability also becomes a bigger challenge because confusing because of the way we sense the environment around us by touch and feel is very different from how we consume it using vision. So in case there is conflicting data, it is quite difficult to understand what to make of it. Therefore, accuracy, availability, and low latency are key drivers. In Muneeb's presentation, you will also see that at least for some time, high bandwidth requirement will also be a key driver for such applications, because the feedback will not be limited to being that of touch. We will also integrate audio, maybe not for this build-a-thon, and video feedbacks, so as to ensure that the machine performs tasks as are expected of it. So this is how this build-a-thon has, or this particular challenge of the build-a-thon has come to be. So you have on the one side a test bed which has reached a reasonable level of maturity, and on the other hand, there's this thrust to apply more and more of AI ML in newer modalities such as haptics and 3D. Our current focus, of course, is haptics. At some stage, we might also handle 3D as the part of our XR or AR and VR push, where we want to also enable augmented and virtual reality with the aid of moving computing to the edge. I'll primarily be using this slide with me. So moving on, before I talk about the architecture that we see here, a couple of things to understand is why do we need an MEC? So traditionally, what was happening was very early on when the computers were formed, the most of the compute used to happen at a central server, and it was also not connected. People would have to go to that central server where, if you were to look at its configuration, it would look more like a feature phone configuration than that of a mainframe. But that is how people used to compute, to go to a central place and do all their computing right there. With the advent of connectivity, Ethernet, people started having thin clients and accessing the server. And when the number of thin clients started increasing, people tried to move more and more of the compute at the endpoint. So there was this shift from mainframes to good compute capabilities. And then when the requirements of the task, the data scaled to levels that were almost impossible to handle, and the number of endpoints became very large, then again people had a clear push towards cloud-based solutions. More recently, what has happened is that, driven by needs of privacy, security, low latency, and of course distributed computing, because there is a limit to how much you want to load your cloud server, people are now slowly moving towards the endpoint. And this is how edge computing is being looked at as a viable option for handling the large amount of compute that you need to do to make applications run. And this compute has to be done with low latency, ensuring that whatever is required is done in the time that is available. So low latency applications are enabled. Load is taken off the cloud. The delays that are inherent if you take everything to the cloud, compute and bring the result back, are taken care of. The need for handling privacy at the cloud goes away, because the data does not go beyond the edge. And these and other reasons have resulted in edge becoming the go-to method for handling such tasks. What has also happened is that there has been a clear converge of compute and comm. In earlier days, a computer and a communication device were usually two entities, and today there is a very, very clear convergence. You cannot have one without the other. So most compute devices have reasonably good comm capabilities, and vice versa. So this compute and comm converge made it easy for having a network element within the network architecture to handle some of the compute capabilities that were required of an application. So this is how MECs come to be. So we have a particular implementation of MEC here at IIT Delhi, and Arzad will talk in more detail about it. Okay, these are the details that I leave for Arzad to handle. If we can move onwards, we will spend a little time on. Okay, so just the setup, because you will hear a lot more of this today. So the kind of setup that we're talking of here is you have a haptic glove on the one side and you have a robotic hand on the other. The idea is enabling dexterous manipulation of objects by the robotic hand, and this requires a lot of things to be fixed before this becomes commonplace on the regular kind of telecom networks that we are aware of, or we've become used to. So a few problems that need to be addressed, I'm going to mention very, very briefly. Some of them will be heard, you will hear about in detail in the later presentation, but some of them are beyond the scope of the current Build-a-thon, but very, very central to this becoming a success. So the first problem that we face is that related to the endpoints themselves. These devices, unlike the phones and computers, are not built to easily connect with the network. Most of these devices have their own controllers, and you want a dedicated connection between the controller and the device to control them. So the operating system, if you can call it one, even though ROS is termed not as a OS but as a collection of capabilities that make the device run. The problem is that while building such devices, not enough care is taken to ensure that they can seamlessly communicate or be connected to the kind of architectures that you will encounter for communicating. So even though you want these to operate remotely, it is extremely difficult for the other end, the remote end, or where the teleoperator is, to connect seamlessly to the robotic hand or whatever dexterous device you have at the other end. So this is where the first problem arises. And when you will hear Muneeb, you'll understand that even for the particular setup that we have here, while you have haptic glove on the one hand and the robotic hand on the other, both have their own ways of sensing data and measuring data and reacting to data. So now what happens is, because of the way, because there is no uniformity or standardization even in the way data, the environment needs to be sensed and the hands be constructed. So you have a difficulty right there. So two difficulties at the endpoint itself. One is it does not plug and play into network architectures, and the second is that there is no standardization vis-a-vis the kind of sensing and actuation capabilities that these devices should have. So this is one issue that needs to be handled. The other issue that needs to be handled is that people talk per se about low latency, high availability, high accuracy kind of requirements, and they work on those in general because there aren't enough haptics devices going around. So the way the network is evolving, it is looking at those requirements generically. However, there has to be a more specific view of what is expected to make such devices work. So this is where the MEC implementation that we have here starts playing a role, because the MEC that we are doing is the effort is twofold. At one level, we want it to be as general as possible for enabling all kinds of low latency applications. But we are also reasonably clear that one of the capabilities that we will want this particular setup to be able to support is haptics. So for this reason, haptics is our application or use case of choice for most of the development that we are doing. The other thing that is of importance is understanding the human intent. So when you work with videos and you work with the audio, a lot of times the requirement is simply experiencing what the other person's trying to say or capture, but at other times you have to make sense of what the person is saying, so that you can have, for example, a logical, sensible conversation. At other times, the machine should be able to take decisions about, for example, security breaches or surveillance related triggers. So here also, there are certain such needs that exist. You need to understand what the teleoperator, and the teleoperator here means the human who is trying to manipulate the device at the end location. What is the person trying to do? Such knowledge and interpretation will help make the actuation process a little better. So some of the work that has happened out of this lab is on predicting the intent of the teleoperator, so that if there is per chance a break in the network or delay in the signal reaching the hand is able to take the right set of decisions. And because of the non-standard implementations of these devices, we also needed this for the scenarios where the network was up and running in the manner that we wanted it to. So these kind of things have become critical. So the need for an AI stack, which is distributed across the endpoint, the MEC, and the cloud, is central to ensuring that such applications run well. Because the eventual goal, of course, is that you do not have a human in the loop. So there is no explicit teleoperator. The robo senses the environment and receives generic commands, and based on sensing the environment and possibly a command for the next hour of duty, it performs whatever tasks or activities are expected of it. Next slide, please. Right, and so this is a bit about. So what I've tried to do is talk about why haptics, why a build-a-thon, why MEC, and what needs to be done in haptics. Another one specific aspect that we want to work on is, and when you will look at these build-a-thon challenges, you'll notice that they are centered towards the use of AI ML in haptics, and we have tried to stick to the goal of understanding the intent or making the endpoints smarter in the sense that they extract more from what they are sensing than a plain raw signal. So most of the challenges, as you will notice, are around that. And what we also intend to do is, because we already have a test bed that is mature and we have faith in, the team that comes up with the most practical and most promising solution will be allowed to come work in the lab for some time and implement it on this real working test bed. So for the chosen team, they will be allowed to implement their solution on a real working test bed and set it up as a demo for the world to see. And before I end, a couple of words about the other activities that we do in the lab. So the Samsung Innovation Lab at IIT Delhi is where the people sit there, but the activities that happen here are not limited to Samsung collaboration. The 5G related activities to the MEC also happened out of the lab. We also do a lot of work in the area of computer vision, AI and ML. So like Pimi said, I did my PhD in the area of multi-rate signal processing, but my area of interest is signal processing, but signal processing has slowly evolved to encompass AI ML, even though the AI ML community would believe otherwise, that AI ML was a technique that consistently performed better than signal processing, and the signal processing folks keep feeling that it's a lot of hand waving and without enough mathematical foundation. But irrespective, what has happened is over the years, there's a clear move towards more and more AI ML being used in activities out of the group. The other area is that the other activity that happens in the lab is the use of these AI ML tools. So we are looking at all three modalities. We are looking at audio, we're looking at video, and we are also looking at haptics. So all three modalities are being handled. Right now, bulk of the work is happening in the area of computer vision. This is the list of some of the projects and collaborations that we have. This is where I want to end. Do we take questions here? I think in the end, right? But there were a couple of comments. Can you check if there are questions, or should we then hand it to Vishnu ji after you introduce him? Because he has some very interesting stuff to share with the audience. So we have something in the chat, right? So just
It
check.
was mostly the registration link. No questions as of now.
So we will take questions, if any, towards the end. So the last session is about question and answers. We will do it. So kindly go ahead and introduce Vishnu because he's the next. Thank you very much.
Thank you, Professor Lall. Next, we have Mr. Vishnu. Just give me a moment. Mr. Vishnu Ram will be giving us an overview of this challenge, both at the India and the global level. Mr. Vishnu has an hands-on experience in the field of telecom industry for more than 2 decades now, developing and implementing standards and holding various international granted patents. He was nominated to Scientific Advisory Board Associate Member for Motorola Networks and the IIT Future Tech Panel. His last industry position was Senior Specialist at Nokia Networks in Radio Resource Management. Since 2018, he has been working as an independent researcher and is the co-editor of ITUT focus group specifications on ML in 5G. His current work items include coordinating standards initiatives, license with other SDOs, industry, open source and academia, and he has been mentoring student projects and coordinating with the ITU AI ML in 5G challenges across the globe. He holds a master's degree in computer science and engineering from IIT Delhi. So as Professor Lall said, Mr. Vishnu has some very interesting context for the students. I now request Mr. Vishnu to please take over.
Thank you so much, Pimi. Yes, I will take the sharing. Just a moment. Okay, I hope you can see it in full screen, no, Pimi?
Yes, sir, your PPT is visible, but it's not in the full screen mode right now.
Is that so? Okay. Let me try again. Now it should be.
Yes, sir.
Thank you so much. So first of all, welcome to everybody. I see that we have our international partners also here. Welcome to everybody. And also it's a pleasure to talk to all these colleagues on behalf of our partners, IIT Delhi, as well as on behalf of TSCSI, ITU, India, UICT. We are very happy to present here. Thank you so much for this opportunity. So today my role is to introduce this package for ITU Focus Group Autonomous Networks Build-a-thon 2022. I will use a set of slides. I will take about half an hour, and then I will also introduce this GitHub website which we use to host some material. So that's the agenda for today. Just a moment. Let me try to. Okay. So right. So this is the introduction to the Build-a-thon itself. What is Build-a-thon? So you see, Build-a-thon is a problem statement under ITU AI ML 5G challenge. So that's the first answer to that question about what is Build-a-thon. And it is hosted by this ITU Focus Group Autonomous Networks, and Brejesh, Professor Brejesh has been very kind to host the India round for this Build-a-thon. So we have a very good opportunity to increase the participation and win some prizes. So I will come to that in a bit. And we also aim to demonstrate and validate some important use cases. Brejesh just now talked about some of them, very interesting use cases. And Professor Arzad is going to come after me to talk about very specific use cases which are part of the India round, right? So I am going to take a very overview about what the competition is about, how to win the prizes in the global level. That's what I'm going to do here. And to introduce what resources you have from ITU focus group side, what we can offer you for that perspective. Plus, as Brejesh already mentioned, we have a specific lab and testbed that he already covered, and Arzad also will cover about that. We are aiming, this particular problem statement aims to create a proof of concept implementation and tools in the process of development, right? So it's not only about AI ML models, as Brejesh correctly called it, you know. So it's not only about AI ML. We would like to create end-to-end, exactly like what he mentioned, end-to-end, take a use case, show that. That's what we would like to do as part of this. It's a common open platform. We want to build something to prove a point. And it's a proof of concept development activity, as you must have seen right now. Key concept is to be demonstrated. What are these key concepts? I'll come to that in a bit. And we would like to show this with code, test setup, and a demo setup. We don't create the product. The code which we produce as the teams produce as part of the Build-a-thon is not considered product quality software, as you might be very well aware. We would like to create well-documented artifacts like open source code, and here you see there is Venn diagram which shows what is the relationship between overall challenge and the focus group as such, what we are doing at a global level. So you see on the left side there is overall challenge. I will show you some slides on that, not too much, but just an introduction of overall challenge. On the right side, you have this focus group activities, but in the between, in the intersection, you see this Build-a-thon where we select few use cases like the haptics use case, MEC use case that we will go into details today. And then we host an open repo and we develop and show the test cases and demo. How to participate? That's going to be the next question, no? So that's how to participate. It's open to anyone. Participant could be a student, you could be a startup, you could be a small enterprise, whatever, okay? And you're welcome to form a team and submit solutions. What are these solutions? I will come to that in a bit. We prepare mentoring sessions. We have notebooks which host the reference solutions. I've been fortunate to have very good support from experts all across the world, who are some of them are here, right here. So we have actually good support to create these notebooks, and we have published them here. I will show them today as well, and the tools and tutorials to use that as well. I will go over that very briefly. So we have mentoring sessions. We will have those. In fact, we for the registered teams, we have been doing that very regularly. You can have a mentor. There are many good mentors in this call. You heard one right now. Brejesh is a very good mentor. You could have other mentors from your university, from your teachers, from your professors, from your team leaders, whatever. If everything fails, call me. So we do provide mentorship from IIT side as well. What should I do as a participant? What should you do? What are the tasks for these participants? You should select a use case. You can select the use case that we just now went over, and Arzad is going over. So you take this use case, you draw the design of the use case. This design we suggest you draw using a graph. I will show you some examples. So the way we go through the use case is that you design the use case first, then you create the implementation, and then you demo, right? So you know this process, right? So you select the use case first, then you design the use case next, then you would implement the use case next. That's how the three-step process, right? So you can use this type of a model where you select, design, and then you implement and demonstrate. Please don't forget to register. This is the registration link. There is also ITU registration link, which I will show you in a bit. You can, if you are interested, you can introduce yourself. There is a discussion in the GitHub. You can introduce yourself, say hi to others. If you have questions, you can ask in the GitHub. You can ask me now also after Pimi opens the floor. So these are the deadlines. Don't forget, we have deadlines. So we have so registration is already opened. We are in the data preparation is over. We have six use cases which are referenced and produced as part of ITU effort. Of course, for the India round, Brejesh, Professor Brejesh and Arzad will talk about the data which is available from the test bed, and they also have opened the test bed for you. So thank you very much for that. We had a kickoff workshop on June 3rd. That details are here. There is a Build-a-thon kickoff workshop recording also available. We had 118 participants from across the world and registered, and 74 of them attended, and there has been recordings which are accessed as well. If in case you missed it, I think it was a quite exciting session. We had a vice president from Rakuten Mobile motivating us, as well as there are other very interesting speeches, technical details which were given as part of this, as well as also teams from across the world presented their perspective also. So if in case you missed it, please look at the recording. Then we are having these kind of webinars, podcasts across the world. We are thankful to this initiative to host this webinar. I have to change this. I thought I changed this. Our registration has been extended. We are now looking at a longer time frame to allow participants to register. We are open till October. Sorry about that date. I will change it. Mentoring support, I already told. Submissions have to come in by about September end. I suggest that. We will have a judging and demo event by September, October. Reports submitted by about October, and we have grand challenge finale in December, May. This is our timeline. Okay. I now would switch gears to show you a little bit about the challenge itself, overall challenge itself. I mean, Build-a-thon, as I told you, is a small part of it. Overall, we are trying to create a community of value to our students, professionals, and we offer this kind of expert talks and webinars. We have roundtables, hands-on sessions, mentorship, and we produce baseline models. As part of the challenge, you see there are not only prices, dollar prices, the OP prices. That's not only one. We have publication opportunities. Professor Brejesh and colleagues have already published actually in ITU journal for future and evolving technologies. So that I will show you in a bit. There are opportunities for training and internship. Here, right here, there is an example. Brejesh already mentioned the lab is open for those who are selected to come and work there, right? For me, that's more important than the price. So given an opportunity to go and work with him, I would probably give a hand and a leg, okay? So that's what I would grab to work hard for this kind of opportunities to go and work with him in the lab. Collaboration opportunities exist for across the world. Job opportunities, there have been cases where participants are recruited not only for internships, also for job opportunities. So in our surveys, we see that 92% of them recommended the challenge to a friend or a colleague, and we have very good satisfaction rates. These are the numbers from previous overall challenge. You see there is good participation across the world. Okay, I come to how to win prizes. So the first thing is that you should know what use case, as I told you, follow the 3-step process, select the use case, design the use case, implement the use case, and done. Okay, so that's a very simple 3-step process. I leave it to Professor Arzad to explain these details of each use case and the steps. But from a selfish perspective, how to win prize, right? So that's what you are asking yourself. So you should be active in this GitHub forum, create this design, use case, and demo, create a nice use case and design and demo, contribute it to us in the sense the focus group, create a video of the demo, upload it to GitHub, all this is possible. Code which you have to implement it, please implement only the part which is open source, that you should submit it to the repo. Map it to standards, because we are basically a standards body, right? So it helps to map it to standards. That is, your mentors will help you to do that. Otherwise, we will help you to do that. That is mapping to the standards part. Wherever possible, automate. So automate using, you can use whatever you want. You can use natural intelligence, artificial intelligence, machine learning, whatever you want. Automate it. And right, so we would like to see this evolution where I will come to that in a bit. Specific concepts to be designed and implemented as part of it. For example, to optimize the latency in the haptics use case that Brejesh explained. You could work in teams, you could reuse, but you should give credit and cite them. Publish the Jupyter notebooks as exactly what you see in the reference implementations. There is opportunity to publish in IIT journal. You see this paper, you see Brejesh is right here. This is in 2021, sorry, 30th July 2021, we have published this exactly a year back. So yeah, so we had this published from this team in IIT Delhi. Now I switch gear to use cases, how to design. So that's this part of the talk. There are documents available. I'll show you that in a bit in the GitHub. But let's look at what tools we use and what are the design tools that we recommend. We recommend the use of this tool for graphs. We recommend the graph-based implementation. In our reference implementations, we use this graph-based tool. Neo4j is the graph database. Some of you may know it. You can use whatever tool that you like. You need not use this kind of a tool, but it gives us ability to query, ability to manipulate, to apply this AI/ML much easily if you use such a tool, well-known tool. So you can use this. There are queries which we have given here, and in the GitHub, the reference queries which will allow you to design, build, and query these use case design. I will show you in a bit. Let's take one sample use case. This is actually use case 6. When I say 6, it means that whatever focus group has published. It says here, automation and intelligent O&M of radio networks. This is one of the submissions to us. This is already now published by the focus group. It's just a reference. For the India teams, I would strongly suggest to use this as a reference only. Go to the next talk from Arzad, who will go into details of specific use case. So in this use case, let's just take this as a reference. Okay. In this use case, what are they looking at? Dynamic radio environment. user behavior changes, user distribution changes, so network needs to be monitored and optimized continuously. So this is the closed loop, right? So you need to monitor, optimize, apply it to the network. That's what they are talking about. It takes a lot of time and manual effort needs to be reduced. Exactly like what Professor Brejesh explained just now. So a manual reduction of manual labor. That's exactly his words. Autonomous management includes real-time monitoring and diagnosis, root cause analysis. That's the use case, okay? Now, this use case using this graph-based tool is now modeled in this fashion. So there is, on the left side, you see a generic picture. On the right side, you see a very specific picture. How is this drawn? There is a graph notebook you see in the GitHub. You can see this notebook. I will show you in a bit the GitHub as well as the how to run this. You can use the Colab to run this, Google Colab, I mean, to run this and produce this result yourself. You don't need this slide. So you don't need me either. So you can run this and generate this graph yourself. Okay, that's possible. So this kind of design, you don't need this graph, but this kind of design helps the judges understand what you are, how you are modeling the use case. You can use any tool, you can use any kind of design, but this kind of design helps the judges understand what is the process, thought process that you are following to build the use case. Then let's look at the specific concepts in the focus group, which will help you to win the prize. Okay, so there are three main concepts that we would like to look at. One is this evolution, experimentation, and adaptation. Evolution means as how to handle unforeseen scenarios in the use case. So in the haptics use case, you will see in a bit what Professor Arzad will talk about, the how he is handling the scenarios which appear, the data sets, what kind of data sets are there, and how to handle those, either using AI ML or using any other mechanism, how to handle those unforeseen cases. How can you apply these evolution techniques to build use case, evolve this use case to handle future scenarios. This is what we mean by evolution. Experimentation is exactly the test bed that Professor Brejesh explained. You have a test bed, you experiment there, you create alternative solutions, you declare the winner of those alternative solutions, right? So you have, say, 5 candidate solutions, you build those, you put it in the test bed, and then you come out with a winner, so-called winner among those candidate solutions. You know all this, right? And then you adapt it, create the demo in the network, in the testbed with the winner, right? So you have, you create a set of unforeseen cases from the data, you model the use case based on it, you model the change in the use case using the evolution, you put it in the testbed, experiment those, let's say, top 5 candidate solutions that you have, and then you pick the winner and integrate in the testbed, declare victory, publish the paper. So that's what we mean by these three key concepts here, and probably oversimplifying. But these three concepts, where you model, you play with the model to compose these closed loops, you experiment with those composed closed loops, create sample solutions, experiment in the test bed, then you create a winner or select the best one out of it to implement it and test it in the test bed, integrate and test it in the test bed. This is how I would translate this picture for you. Okay, I'm going to probably skip some aspects of it, but you see, as I told you, we make a controller closed loop which will model this kind of low latency cases that Professor Brejesh explained. This is what we call as making logic. The making logic using evolution means that you make the closed loop from small modules, which we call as components in the closed loop. So let's simplify this and look at implementing, designing and implementing the use case. Then as experimentation part, which is the validation of the logic, as I told you just now. Then integrating this in the network in the test bed to derive some results out of it, so that you have some results which are from the selected candidate. Okay. Then switching gears, 2021, we had a build-a-thon. We had 5 teams from across the world who submitted solutions, and we had a grand challenge finale, evaluation, and 3 build-a-thon teams presented their solutions to this global audience, and top team won a prize from Rakuten Mobile, courtesy Rakuten Mobile. So here is the last year's challenge. This year, what are we looking at? We are looking at creating this closed loop solutions, as I told you, model the use case, experiment with that use case, implement and experiment, and then show the demo. That's what we are looking at in this build-a-thon in 2022. You see here, you start with the use case. I would like to start with step 1. You start with the use case description, okay? Maybe wait for Professor Arzad to explain the use cases. Start with that use case. You design the use case. You can use whatever you want. You can use pen and paper. You can use AI, ML. You can use left hand, right hand, whatever you want to design that use case, okay? And then on top of it, once you have the design, you want to play with that design, select, experiment, and then create some results from it. That's what we mean by this part 2. In that, please keep in mind, we would like you to show unforeseen cases. So in the data which he will explain, look for unforeseen cases, and how your design is able to handle such cases will form an important criteria for us. What's up for grabs? So up for grabs is right here, 5,000 CHF, 3,000 CHF, and 2,000 CHF. These are the awards, and plus we have certificates. Remember, this is for the overall champion. It's not only for build-a-thon, for other problem statements also. So you have to be really good to be really good to win this top prize. However, there is India round prizes. Remember the India round prize that Pimi already explained. There is a trip to Europe. Don't miss that trip. Okay, so there are some references and materials here which I will put in the chat window. Let me skip over that. An important part is that suppose you want the GPU to model, suppose you want a GPU to create a model, train this model. Professor Arzad is dumping a lot of data upon you. You don't have GPUs. You are very sad. Then come to us, because we have a GPU platform. ITU is giving it free of cost. You are able to use this GPU access from. You get a Jupyter notebook from us free of cost. ITU will give this for registered participants. And we have a pre-installed Python and TensorFlow tool sets as well. Okay, so there is question and answers here. You can ask when Pimi opens the flow, or you can ask on this discussions as well. So that's it for this one. I will take the last few minutes to show you one particular thing. Just a moment, hang on for just a second. I will show you, I would like to show you the GitHub so that you know what to expect in the GitHub. So just a moment. Plus maybe what you want to see in the GitHub and where to click, maybe something which is useful to you. So this is the GitHub repo in the chat window. Oh, sorry. I should probably put it to everybody. Sorry. So this is the GitHub repo, and I will share it in a bit. Just a moment. I hope I'm sharing the right thing. It looks like that. Okay, so you can actually you don't need me. You can actually go to the chat window and you can actually open it right there, locally in your PC itself. If you do that, you will land here in this Build-a-thon 2022 website, and you see a bunch of contents here. Whatever I told you just now mostly. So you see what is the Build-a-thon. There is a bunch of material here. Whatever I told you just now. Okay, and plus I would also like to invite you for a global workshop which is here. This is our workshop 2.0. This is happening on 2nd of September. So if you are participating, especially if you are participating, I would suggest to click here, and you can click on this image or register here. You can click here to register for this workshop. Now, the notebooks, that's what you're looking for now. So notebooks, you can click here in this notebooks folder, and you can see the reference code which is here. So this is the first notebook. That's the Build-a-thon graph that I showed you. This is the Build-a-thon notebook. This you can actually directly single click open this in Colab and run it. Or if you're using ITU Compute, or if you're using IIT Delhi Compute, you can do this in a Jupyter notebook. Okay, this will run as it is in a Jupyter notebook. So you can. This is what we do. We start here. Yes. So you can use this for all whatever purposes under the sun. Okay, I give you complete license. So there are some references here. You can use these references. There are prerequisites which are called out here. It takes a few minutes to run these prerequisites, and then starts the code. So you start with importing the dependencies. You start with the password, your URI password, and then you install this. Then you import this. Then start the definition of the helper class. We have done the hard work for you. The helper classes are all in place. So you just need to come down, run this cell, and come down to instantiate the helper class. And then you can start with examples. There are many examples. So you start with example 1, 1A, 2, 2A, etc. You can actually add more examples and try out things if you like. And then you clean up the DB. This DB, by the way, is free of cost. So you can run this DB, create and clean up this DB, and then start the use cases. So here on starts the use cases, use case 1 and the 2 and the 3 and so on. When you run this, what happens? So when you run this, you will get the graph that I showed you. Okay, so you can see the graph. It's created exactly the graph what I showed you. You will get this, and you can model your own use cases using this that Professor Arzad will talk about in a bit. So then at the end of it, you close the database connection and go home. That's the reference notebook for this particular one. You have other notebooks also which are here, which are used for parsing, automating, etc. that we will talk about in the mentoring sessions. You can contact us from discussions here. There are discussions here. Yeah, here is where we are. So this is the India webinar that we are in here. You can click here and say hi, introduce yourself if you like. There is a bunch of questions here. If you like, you can click on Q&A and you can see the questions people have asked so far, what we have answered. You can add 2 more questions if you like. If you like to see your friends, then you can see here, there is teams which have registered so far. I see Mansi from IIT Delhi. Thank you so much. There is also other teams which you can see here. Registration is by clicking in this link that I showed you. From here, you click on register for Build-a-thon. Here, you click on here and register for Build-a-thon. You can click here. I will also put this in the chat window, as well as I will put ITU link for registration in the chat window also. No worries there. So that's it. I hope I am on time. Thank you very much. And I'm available for questions. Back to you, Pimi.
Thank you so much, sir. Any questions from the audience as of now? Or we can take the questions later after Professor Arzad and Muneeb have completed their part. Is that fine? Okay, next, our next speaker is Professor Arzad. Professor Arzad is an associate professor at IIT Delhi. I would request Professor Arzad to please take up. There's some issue with the screen. We are unable to change the slide.
Hi, Kimi. Is my screen visible?
Yes, sir, we can see your screen.
Okay. So I'm putting it on full screen mode. Thanks, Kimi. Thanks to Professor Lall and Vishnu ji for excellent introduction. So my job is in this presentation slightly on kind of acting as a bridge where I take over or continue what was discussed around MEC and then slowly migrate to what comes next, the details of the build-a-thon or the problem statements that we are going to cover. Okay. So I actually always start with this very interesting slide, which I got from a 1977 paper, which talks about the convergence of compute and communication. Most of us are fortunate enough to have seen this now, and we are seeing the evolution of this convergence itself now. The boundary between communication and compute is getting more and more and more blurred. And what better example than edge computing? Let us see how edge computing will help us, or how edge computing fits in this compute versus communication integration. So expertise from both the fields, computation as well as communication, come into play here. They get integrated very nicely and to solve some problems which are very, very interesting. So I feel that we have very exciting times ahead. We are already seeing 5G. So those of you who have seen the evolution from 2G, 3G, 4G to 5G, 5G is the first kind of technology where there was no monolithic requirement from the system. So 5G had this EMBB, MMTC, URLLC, 3 different segments, right? So before that, 2G was more about voice call, then 3G came in, select some amount of video and transition to the data packet networks, and then 4G was all IP kind of setup, right? All data packet, all packet-based network. But they were all monolithic, so they were all catering to one particular use case in some sense. 5G is the first point where things started digressing, so digressing or expanding. So you can call it, you can use either term for it. So EMBB, URLC, and MMTC. We feel that more and more of such kind of diversification will happen in the future. 6G will see many such dimensions. That's what we feel. We are actively participating in 6G standardization also. Some of the very important applications of 6G, you can see are mentioned here at the right. So you will certainly see more of VR, AR, Industry 4.0 robotics, and so on, right? So these things are becoming more and more practical, and you are seeing all of this being actually deployed in the field. And if you compare, I mean, what you see right now are the basic versions of this solutions. In next decade or so, you will see much evolved, very evolved versions of the solutions, and that is what we are looking forward to. When we come to MEC, so just consider this example where you have all these standalone cameras lying around. So it's so many places. It's very easy to install this kind of standalone cameras nowadays. And who processes them? Essentially, some kind of public service provider who is getting the feed from all these distributed systems and then doing this kind of processing, right? Eventually you would be, so currently you would be just relying on manual intervention. However, you can see that it's not very good. It's not very optimized. It's not very efficient to rely completely on manual intervention. There also now comes the compute part. So this is the communication. We are able to get data from one point to another to the control room from many such distributed sensors to a common control room, which is, so this is basically communication has done its job. Now comes the compute part. In terms of compute, there are many evolved algorithms available which can do image processing, video processing, and so on. And they can essentially replace manual labor, right? So they can do the processing in an automated manner. For example, there are many algorithms available now which can detect build-up of a crowd or a mob at some place, right? It is very good for law enforcement authorities. There are many such examples available. So what is the problem with this kind of setup? One of the problems with this kind of setup is that we are relying on this green communication type of some kind, right? Where the end data, the end sensors are collecting data, they are sending this data through the operator network and the external network, and then goes to the cloud, right? So this cloud is the end user of this kind. If we are interested in some particular events, right, why don't we have the information or that kind of intelligent logic at the cloud, close to the source of the data itself? Because if we are only interested in onset of some event, right, then we can save this complete green data pipe going from our traversing core network and external network, thereby saving bandwidth here and also time. So both of this can be done here. Bandwidth and time can be saved. Further, the compute requirement for this end device to continuously and in parallel process so many data streams would be tremendous. We can actually distribute that also across the edge, right? So the edge, when it is opened up, so one of the key things is this is very natural to say that we can do it at edge. Why was this not possible earlier? That is the question, right? Why are we talking about the edge now? It was possible earlier. People were doing this edge kind of solution in many different avatars. Only problem was that we did not have a standardized way of doing this edge available to us, right? Compute at the edge available to us. So now that is available to us. So we know, so as from IIT Delhi and IIT Delhi, we are actively participating in this standardization efforts. And HC, 3GPP, and TSDSI. Here is what we are actually doing currently with this standardization bodies. You can see that IIT Delhi is currently very actively involved with the tactile and multimodal aspects of the edge computing application. The left side gives a mapping of the complete MEC architecture solution and who is doing what in this domain. So given that now we have a standardized interface available to us to achieve this kind of integration, what this does is helps us take the problem to many intelligent people like you who are participating in this build-a-thon. You think about the applications. We are providing you with the communication infrastructure, and we are also providing you with the hooks to integrate your solution with this network. So you don't have to worry about the nitty-gritties of how you are going to communicate with the end device and so on. We are providing you with that pipe. You just focus on your application development and don't restrict your thoughts. You can do lots of things here. There's huge opportunity you can see. One of the things so this is about the edge computing, its solution, why it is available now while we're talking about it now. Right? We are interested in this build-a-thon is more focused on tactile applications, where our main objective is to achieve very small latency. End-to-end latency will be small. The requirements will be very small end-to-end latency. There are many use cases, for example, telesurgery, digital twins, autonomous vehicles. So you can see that there's a very, very big application domain. And if you are participating in this build-a-thon, you will get the detailed engineering requirements of designing and developing these applications. As an academic institute, this is what our objective is, to spread the knowledge of engineering requirements of different applications. And in this, we thank the support from ITU, Vishnu ji is here, who has helped us with this. So we are just trying to make sure that we have so many very well trained, you have thought about all these problems, so we are taking these problems to you. You think about it and how you should be solving it. And when you integrate this with our setup, you will see what are the engineering challenges. Okay. We feel that, so it's very easy to say that MEC helps, but I must remind you and caution you that MEC is not a solve all kind of setup. It is not going to solve all the problems, right? There will still be problems. You will have to, it's not that you just put in MEC somewhere and then all your problems are gone. That is not going to happen. We have to be aware of the pros and cons of MEC. So briefly, I'll talk about how we have integrated, because now, as I said, that standardized way of integration is available now. So in our IIT Delhi 5G testbed, we have followed this the right hand side is the HC recommended, the HC architecture for MEC. We have integrated it with the 5G core system. So left hand side is the 5G core. We have made this integration. So effectively what you have to do is, when you create an application, you have to just implement this client application. All the other communication aspects we are going to take care. There is an MEC host. You have to just give us your application, which kind of taps into the data requirements. So that also you have to tell us what kind of data you need, and you will get that data here. So at the application layer, you are basically going to write this client application, MEC service application, and the cloud application. Everything else we are going to do, including the best MEC platform. Because if you see in this particular architecture, many base stations can have an edge host attached to them, right? Which edge host is best for your application? We will be able to decide it for you if you give us your requirements, right? So all those kind of optimizations are available to us. Because we are talking about haptics application, what we have done for this build-a-thon is prepared this particular setup, where on the UE side, UE is the user equipment side, we have an Allegro hand, and on the right hand side we have a haptic glove. We have made sure that most of the nitty-gritties of the MEC aspects are captured in device application, which you don't even need to worry about. You have to just write client application. We have provided write APIs. There's a very small APIs list. We have not made too many APIs there. With a very small minimal set of APIs, you can just communicate with the device application and make use of the MEC platform. Okay? You will have to write this MEC service, which will run on the MEC platform. So that's basically what you have to do. So to make sure that you are not required to have this kind of hardware setup, right? We have also made sure that there is a simulator available. So we have used a simulator, which Muneeb and Gaurav will talk about after me, so that all of you, whatever solution you are creating, they are based on the standardized platform, and the calibration is easier across all the entries, right? So this is just an example of the interface that you will see when you use this particular simulator, Allegro HIM. So now I come to brief description of two problems that are part of this build-a-thon. The details of this and how the data will flow and what kind of data is there will be discussed by Muneeb and Gaurav. First one that you have to do is force estimation plus slip detection. Okay? So if you look at this part, effectively what I have shown is that there is a hand which is picking an object. So this object has been lifted. Now there is a continuous gravitational pull applied to this object. Slowly, depending on the friction coefficients and all, and also depending on the gravitational force and external forces, this object may start slipping, right? So think of this as any, you can map this particular scenario to many telesurgery, teleoperation, robotic and operations. You can map them, right, to others. For example, this is a kind of a bomb being lifted, some kind of suspicious device or suspicious object being lifted remotely in an airport, let us say. So you can map this abstract problem to many other real world problems, and there's no end to it. So now we want to make sure that once this object has been lifted, then it should not slip. Or if there's an onset of slip, we are able to detect it quickly. Now the key term here is quickly, right? So if this data from the object, from the robotic hand is going to the haptic glove, eventually the haptic glove will also be able to detect the onset of slip. But the problem could be that these delays are high. So your haptic glove is, your robotic hand is here and haptic glove is here. This could be delay of order of 300, 400 milliseconds as well. And the delay from here to here could be 10 milliseconds, 5 milliseconds, 20 milliseconds. So that's an order of magnitude delay difference is what we are talking about. So running such slip detection algorithm at the edge and quickly applying a control back is what we are talking about. Okay. So what you have to do is find that the object. So we will give you the base framework will be, or the starting point will be, that object is already currently held by the robotic hand. The object, so this, the starting point will be completely completely described, even using the right parameters for that setup. Okay? What you have to do is find out if the object is about to slip. This will be done at the edge. And if you find that the object is about to slip, you have to apply the appropriate control to prevent the slip. This is the first problem. Okay. Then the second problem is of object detection. Even though this looks very simple, we may always not be able to rely on the visual cues and all. So we may have to just identify the object based on the interaction of the robotic hand with the object. So in those scenarios, the request or the problem statement here is just using this data coming out of, and Muneeb and Gaurav will talk about how this data will look like. You have to identify the shape of the object, right? So these are the two problems. With this, I will stop here. And if there's any question, we can discuss. Else, I will request Kimi to see. I think Muneeb and Gaurav have to discuss next.
Thank you, Professor Arzad. Thank you so much for this informative session. Now, since we know about the problems identified for the build-a-thon, next Muneeb will be presenting. He will give us further details as to with regard to the available simulator. Muneeb has received his master's degree in computer science and engineering from Jamia Millia Islamia University, and he is currently a PhD research scholar at IIT Delhi, working in the area of teleoperation of robots. So essentially, all the details that have been provided by Professor Arzad, who has been heading the MEC team here at IIT Delhi. Further to this, Muneeb will give us the details of the simulator, the availability of data sets, and the support that the IIT team, especially the MEC team, would be providing to all the participants during this entire activity. I now request Muneeb to please give us the details on the technical part of this build-a-thon. Over to you, Muneeb.
So good morning, everyone, and thank you. I'll talk about the technical aspects of the activity. Let me start with the system setup. I'll talk about the details of the system that we have, which will be followed by the data set that we'll be providing and followed by the evaluation. I will take a minute to discuss about the teleoperation scenario that we have here. So there is a haptic glove that's worn by human controllers that sits somewhere remotely and tries to manipulate the state of the robot. And now there are two things that are essential here. One is that this kind of communication is critical to latency. In some critical applications, latency might be a challenge. The other thing is that while the human controller is trying to manipulate the state of the robot, there is a feedback channel wherein the human controller wants to know what is the state of the robot after it has given certain kind of instructions. So that kind of forward channel may contain multimodal data, as in that could be vision data, or that could be auditory data, or signals or something. So taking both of these in consideration, so vanilla URL LLC component of the 5G may not be efficient to meet this specification. The other thing that I want to talk about is now imagine that the human controller is trying to pick up some fragile object, or let's say a bulb or a cube or something, and that object tends to fall off from the grip of the robot. In that case, the signal that is sent back to the human controller, and the human controller will take some kind of action to mitigate this issue. The round trip time may not be sufficient. That is why we are leveraging some modality here, which is that we are placing an edge server that stays close to the robot. As and when certain kind of an event, in this case some slip occurs, the edge that continuously senses the state of the robot will take a preventive action. First it will detect that action, and then it will prevent that action. I'll talk about what kind of data this edge senses in a short span of time. So obviously the orchestration of actual hardware was non-trivial for providing it to all the participants. So we have simulated our setup. So you will work, your algorithms will sit somewhere on the edge that will sense the data from the robot, which is our Allegro hand in this case, and it will take an action based on the relevant task. We have simulated this Allegro hand on top of an ARM, and we'll be using a PyBullet simulator. We have collected all of the data through this simulator, and for any of you who wants to see a workaround on how these things work, is welcome to use these tools. Let me talk about the robot here. So this is the right hand version of the Allegro hand, and it has 16 joints marked by the axes through which it rotates, marked in orange color. Yeah. We'll be only using the data that pertains to this Allegro hand. Since it's mounted on top of the arm, it's just for using that arm to pick up that object. Otherwise, the data is only will be only restricted to what comes out of the Allegro hand. So we have 16 joints that come from the Allegro hand, and yeah. So the open source software links for accessing and knowing the specification of the Allegro hand are mentioned in the links. Okay. So as Professor Arzad also said that that while trying to pick certain object of interest, there are different phases that are involved in this. As you're seeing that when the robot tries to reach to the object of interest and tries to grasp it and ultimately lift it, its current state is marked, it's recorded and defined in terms of its angle configuration and the forces exerted on that joint, what we call as kinesthetic data. Here's a controlled slip environment that we want to demonstrate. So So we have this Allegro hand mounted on the arm. Some kind of an object will be spawned, and it will be tried to, the Allegro hand will try to lift it up. This way, the angles of the robot change, and so do the forces that are exerted on these joints. While it tries to lift it up, the object tends to slip or does not slip, depending on how efficient the control algorithm was. This was a control slip environment as a demonstration, which will be one of the tasks. And now let me take a minute to talk about the data that was registered while doing such kind of an activity. So while the robot was trying to reach to the object, we have plotted a basic resultant force of one of the fingers, on tip of one of the fingers, since there are 16 joints. So this signal refers to one of those 16 parameters, and different kinds of phases are recorded here. You could see there is reaching to the object, then it is grasping. We could see a spike. There are some high frequency components while picking the object. Then there is a dip that marks some kind of an trigger event. Okay. So about the data, there will be 16 joint states. We won't be taking the configuration of the robotic arm. So the forces that are exerted look somewhat like this. And there are also the angle state configuration, wherein one will get to know what was while having these kinds of forces exerted on its joints, what was the angular state of those joints. Okay. So using both of them, the structure of data looks something like this. So since it has 16 joints, so you could see that it runs from 0 to 15, and each of the joint will have its angular value. And yeah, just a second. Yeah. So there will be an angular value and the resultant force that's experienced on that joint. So there will be 16 such joints, and this will be followed by a label that is relevant to the task. Since there are two tasks here, the labeling part, we'll discuss it. We'll talk about in due course of time. Okay. The evaluation will be done in a phased manner. Initially, we'll release the training data. This will be followed by the validation data, on which you will record your numbers. The ultimate scoring will be done on undisclosed test data, whose distribution will be similar to the validation data. The last part of my discussion is what to expect within data. There will be redundancies. Yes, there will be noise in the data. There will be outliers plugged in, or that kind of challenge. In fact, data processing itself will be a challenge as a part of this activity that the participants will have to tackle. So that's it from my side. Over to you, Penny.
Thank you so much, Muneeb. Now, since we are quite clear on respect to what all activities would be going on as part of this build-a-thon, how to register, where to register, the relevant links, details on the problem, the support from the IIT team and from Vishnu sir. I now request the participants and students to kindly put forth their questions. Are there any questions from the participants? You can put them up in the chat box. Any queries regarding the registration or anything?
Pimmi, there is a hand raised from Shashwat, please.
Yes, Shashwat.
Hello.
Yes, Shashwat.
No, that is by mistake actually. Something wrong.
Okay. Any other queries from the participants, the attendees?
Maybe I can ask a question to Muneeb and Gautam. Maybe when the data will be available, or do you already have it available and you will publish it, or when the participant can analyze it, please?
That's a good question. Thank you for asking that. So the idea is that we have, if Muneeb has already explained, there will be 3 times data will be released. First is we will give you some training data the day the competition starts and the registration closes. There will be another set of data which would be mostly test that will be released. Exact date we'll let you know somewhere in the middle of the competition, and then finally the test data will be released. Will not be released. It will only be used for evaluating the performances. So to answer your question, the data that you need to work will be released on the date the Build-a-thon goes live, which is the day when the registrations are done. But you already have an idea of the tools we are using to generate data. So for those of you who want to get an idea of what they're up to, they can they can download some of the data there and see if they can work with such data. All right, but exact data on 12th of August is when that data becomes available.
Thank you very much, Brejesh. Do you also, if I may ask one follow-up question, how can the participant download these tools? Would you give a link? We can of course host it, but if you have a link, please provide it. Also, these slides, I think, of course, the recording will be made available. We will do that, but the slides also will be very useful to the participants. Could you please comment?
Yeah, both things will be done. So we will host the data and we will provide the link to you. So Vishnu, the expectation is, of course, that ITU will publicize it widely, because once such data sets are released, their utility is not limited to the present competition. So the number of people who use this, the better it is for the group and the haptics community in general. So we will host it on a server and try to keep it up for as long as we can, and we will request you to kindly put that up. Also, what we will want to do is, I think this has been recorded, so the recording part of where Arzad and Muneeb speak, if that can also be made available along with the presentations, it'd be a good idea, because people who have doubt on how to use or what the application is might want to go through their 2 presentations. So if somebody can cull them out and have 2 presentations, one by Arzad, which is a high-level presentation, and 2 by Muneeb, which is the specifics of how to use the data and what to make of it.
Absolutely, yes. Thank you very much. I think I really like the idea of more wider application. I think that's exactly what we also would like to do. Thank you very much. I think there is a question from Vinti. May please take it, please. Both industry. Yes, from our side, yes. Brejesh, please, from the India round, what is your comment? Would industry and students participate?
Yes.
From globally, yes, we definitely encourage both.
Yeah, academia and industry are both welcome.
Thank you very much.
And
just one additional comment. The timelines. So we would like, in general, I mean, from my experience, it would be good to increase the time which the participant has to work on. I mean, in hand to work on this problem. that will increase the quality of the solution, as you know from previous experience also, Brejesh. So we would like to maximize that part. So we would maybe encourage Muneeb or somebody to publish the tools and the parts of data that you have right now, and then the final data sets whenever it is available, so that the participant is able to basically start on the problem, analyze it, and then whenever you are done with the final data, they would maybe launch into the final solution, so that they maximize the time they are working upon it, please.
Right. So that's a good idea. So we will release some initial draft, but indicative data maybe in 5 days by end of next month. So
Thank you so much. Thank you so much. Yes, I think that's excellent.
Because of the way we are doing evaluation, we're going to evaluate the performance only in the end. A lot of other competitions have what they term as the leaderboard. While we do not want a leaderboard that continues to be in operation at all times, do you want some kind of a mid challenge evaluation so that the teams know where they are placed, or we can skip that?
That's a tricky question. Yes, I think it's a good idea to engage, definitely. So what we would encourage the host like you to do is to have such milestones, interim milestones, and to engage the participant. That definitely helps to increase the quality of submission and the wider application of the data, as you told. However, in my experience, it may be good to do this in two formats. One is without exposing the details of the solution to other teams. That is one format. So you know the submissions, you evaluate the submissions, interim, you can talk to the participant, engage with the participant. That is, as far as the leaderboard is concerned, we just look at the where each participant stands without exposing the report as such, interim reports or solutions as such. Then another thing which we can do to encourage quality submissions is to have such events, more roundtables as we call it. You know from last time also that we get these participants together, ask me anything. So we call it AMA, ask me anything, where the participant throws questions at you and you answer those questions. There may be different types of participants. They may ask different types of questions. This will also help in encouraging quality submissions. So short answer to your leaderboard question is, we don't really mandate leaderboard. It's up to you, but it helps in encouraging quality submissions in terms of engagement. It need not be leaderboard, but it can be a set of engagements where you take such interim submissions one-to-one, evaluate it, and you can give feedback that will really help participants.
Thank you very much. So if you have no further questions, we can wind up. Any comments that you have, Arzad, before we close?
No, Professor Lall. Only thing is that we need to emphasize that the complete design document is available, and the APIs required for integration are very straightforward. So that's all.
Thank you very much, everybody. Then I'll formally ask Primi to formally close the session.
Thanks everyone for your participation. We look forward to more participation for the Build-a-thon. Thank you everyone. We shall now close.